Okay, so then the next part of the lesson, we are going to now do the last part of the lesson in integration, finding the area of a surface of revolution. So come to the lesson, finding the area of a surface of revolution. Okay, so basically now again, if I remind you what you have learned earlier, you have learned how to find the area under the curve in P1, P2. Then again, you have learned in P3, P4 how to get the volume of revolution. When you rotate it this 360 degree, you learn how to get the volume. Now in the previous section, we learned how to get the arc length. Basically, the length from A to B. Now, in this section, we learn how to find the surface area. So, surface area means when you rotate this 360 degrees, do you see this shape you get in red? So, then we don't get the volume, not the volume, we are getting the surface area. Basically, how much of area is covered by the surface. Shall we write down the equation here? Again, there are a few equations you need to know. So the surface area equation, first one in Cartesian form. So they've given you for a rotation of a curve about the x-axis. Write down for rotation about x-axis. For rotation about x-axis. Cartesian form, they're giving you Cartesian form and parametric form. So Cartesian form equation is the surface area. Surface area equals 2 pi times limits are from xa to xb y times 1 plus dy by dx square. You can see there's a slight difference here, right? In the arc length, you did not have a 2 pi and you did not have this y. Okay, and then there's also the parametric form. I get here y times dx by dt square plus dy by dt square with respect to t. So these are important equations that you need to know. And also they've given you for rotation about y-axis. For rotation about y-axis, they've given you a set of equations. Cartesian form, they've given you two equations for rotation about y-axis. Okay, so the surface area is equal to 2 pi times integration ya to yb. So you get y limits. Ya to yb x times root 1 plus dx by dy square with respect to y. Okay, the other equation is given to you. So these are equations that you need to know. So they are given in your formula book. Some of them are given. The other one is the equation they have given you for rotation about y with x limit with respect to x. 1 plus dy by dx whole thing square with respect to x. And the other one is the Cartesian form x equal 2 pi integration ta to tb x times root by dt square dy by dt square with respect to t. So these are the equations. So we mostly get tested for rotations about x-axis. So these two are the main equations that you especially need to know. Okay, but in an event they say for rotation about y-axis, you must know these equations as well to survive. Okay, so some of these formulas are given in your formula book as well. You can check on it and see. Exercise 4H. So we'll do the question number 1. The section of the line y equals 3 over 4x between the points with x coordinates 4 and 8 is rotated completely about the x-axis. Use integration to find the area of the surface generated. Okay, so basically, you don't need to actually draw. You can directly use the equation, right? So if I just give you a visual idea, do you get what's happening here? 3 over 4x means at x equals 4, you have you have one y coordinate. At x equal 8, you have another. So this is basically your graph. y equal x graph. So when you rotate it 360 degree around the x-axis, so you end up getting a shape like this, right? You end up getting this shape. Basically, what they're asking us to do is to get the surface area generated by this particular shape. So what's the equation we use? So you can see it's a Cartesian equation. So we will use the Cartesian equation for rotation about the x-axis. So s equals, what is the equation? 2 pi times integration y times root 1 plus dy by dx whole thing square with respect to x, and then your x limits are from where to where? 4 to 8. Okay, so let's get it done. So let's get our dy by dx. So y is equal to 3 over 4x, right? We can get our dy by dx. So I get dy by dx as 3 over 4. This differentiation of x is 1. So it's 3 over 4. S equal to 2 pi. Integral limits are from 4 to 8. Y is 3 over 4x into root 1 plus dy by dx square is 3 over 4 square. Respect to x. So I get here 2 pi times integral limits from 4 to 8, 3 over 4x into, can I know the answer for 1 plus 3 over 4 square? 3 over 4 square is 9 over 16. Yeah. 1 plus 9 over 16 gives me root 9, 1 plus 9 over 25 over 16, which gives me 5 over 4. Take all these constants out. 3 over 4 comes out, 5 over 4 comes out. Inside the integral, I have the limits x with respect to x. So when I simplify, I get here 2 into 3, 6 into 5 is 35, or I can simplify actually. 2 and 4 we can cut, right? So I can end up getting here 15, 5, 2 times 4 is 8. My integral limits are from 4 to 8 with respect to x. So when we integrate, we get here x square over 2, right? Limits are from 4 to 8. What do we get here? 8 square over 2 minus 4 square over 2. Get me the answer. 8 square over 2 is 64 over 2. 4 over 2, which is 32. 4 square is 16. 16 divided by 2 is 8. So then what do we get? 15 over 8 into 32 minus 8 is how much? 32 minus 8 is 24. 8 times 3, so 3 times 15, 45 pi. 45 pi is the surface area of the solid generator, the surface area. Okay, is this clear? The same section of line is rotated completely above the y-axis. Okay. Now, previously this section of the line, this was our main section of the line, right? We rotated this section around the x-axis. Now they are saying they are using the same section of line is rotated completely above the y-axis. You see what happens when you rotate it on the y-axis? Your circles come in this manner. Yeah. This is the shape you get from this line. You get something like this 3D object. Okay, are you looking at this? The same section of line is completely above the y-axis. Show that the area of the surface generated is 65. Okay, how do I get the surface area generated? Now, around the y-axis, we have a complete different set of equations, right? So, around the y-axis, I gave you one equation with respect to x. There was another one that I gave you with respect to y. So, which one do you want to use? If you use the with respect to y equation, you will have to get the y limit. You see this equation in here now. When you do with respect to y, there are three equations. We don't need the parametric one here. We need the two Cartesian ones. So one is with respect to y, other one is with respect to x. The one with respect to y has y limits. The one with respect to x has x limits. Which one do you want to go with? You can go with one of the two. Any one of the two is fine. If you use the first equation, you will have to what? Find the y limit. I think we'll go with the second one because I already have dy by dx. Shall we go with the second one? So surface area equals 2 Phi into integral limits are x a x b, right? It was x times, can I know the equation? X times, what was the equation? 1 plus the one with respect to x, 1 plus dy by dx whole thing square. So then let's get this. I think we found dy by dx answer previously, right? Dy by dx was 3 over 4. Do we need to find it again? No. So dy by dx is 3 over 4. Basically, I have the answer for this whole root. 1 plus dy by dx whole thing square answer was 25 over 16. Okay. Then I get here x equals the root 25 over 16 comes out as 5 over 4, and I get the integral of x with respect to x. The integral limits are from 4 to 8. 2 times 1, 2 times 2. So I get here 5 over 2. I get here x square over 2. When we integrate, we get here x integration is x square over 2, and the limits are from 4 to 8. So let's input our values. X equals 5 over 2, 8 square over 2 minus 4 square over 2. So 8 square is 64. 64 divided by 2 is 32. 4 square is 16. Divided by 2 is 8. So basically, I get here 5 over 2 into 24. So again, 2 times 1, 2 times 12. 5 times 12 is surface area around the y-axis is 65. So you would get this exact same answer even if you use the other formula. Okay, so whatever the formula you use, you should get the same answer. However, if you use the other formula, you must get the y limit, which means what? For each x coordinate, you should use the equation and find the particular y value. And then you should get the limits and get the answer. Okay, let's go to the next one. Question number 6, the curve C has equation y equal 1 over 2x plus x cube over 6. Show that 1 plus dy by dx square is equal to this. Okay, so I need to get this show that. Before I go for that show that, first thing is let's get dy by dx. So to get dy by dx, what's the first requirement? Can we have x in the denominator? No, bring it up. So when you bring it up, how does it work? Y equal, how does it come up? Y equals, is it 2x to the power minus 1? X to the power minus 1. 2 will remain down. Be careful, it should be half x to the power minus 1. Be careful here, okay? The 2 stays down, the x goes up. Plus it's 1 over 6 x cube. I prefer to keep the numbers separated so it's easy for us to differentiate. Now let's differentiate. Dy by dx gives me minus half. I brought the minus 1 in front. Minus half x to the power minus 2. 1 over 6 into 3 is 1 over 2, right? 1 over 6 into 3 is x to the power 2. Yeah, 1 over 6 into 3x square. I multiply. So this is my dy by dx. Shall we just rearrange it a little bit? So this is minus 1 over 2x square. 2 into x square. Is this okay? Then shall we apply the equation? Show that 1 plus dy by dx square. So I have to get the answer of this guy. Let's input the value. 1 plus dy by dx square means the dy by dx is minus 1 over 2x square plus 1 over 2. The x square is on top here. So this is dy by dx. I have to square the whole thing. Are you with me? Shall we square the whole thing? 1. Okay, so when we square, can you all tell me? I shall write it twice. Minus 1 over 2x square plus half x square. So squaring means you write the same bracket twice, right? We open, what do we get here? Minus 1 over 2x square into minus 1 over 2x square is plus 1 over 4x to the power 4. Minus 1 over 2x square plus 1. First of all, it's a minus. Minus 1 over 2 into plus 1 over 2 is plus 1 over minus 1 over 4. The x square in the denominator and the x square in the numerator will cancel. The next one, half x square into minus is minus 1 over 4. Again, the x square in the numerator and the x square in the denominator will cancel. And finally, plus half into half is 1 over 4. X square into x square is x to the power 4. So I end up getting 1 over 4x to the power 4 minus 1 over 4 and minus 1 over 4 is minus half plus 1 over 4x to the power 4. Okay, so let's input that value here. So 1 plus 1 over 4x to the power 4 minus half plus 1 over 4x to the power 4. So again, you need to add this 1 and minus half, right? So that gives me again half. 1 over 4x to the power 4 plus half plus 1 over 4x to the power 4. Now, again, you come to a similar situation which we came in the previous section. Do you remember in the arc length also we got a question where we needed to get the square of something. Now, do you see that this expression that I got over here, is it quite different from the expression that I have over here? For the square of the bracket? Do you see it's almost the same, just that the minus half has become plus half. So then do you think you can say what expansion gives you this? Okay, which expansion gives you this? So basically here it's the same thing that both of these brackets are looking the same except the plus minus difference. So you need to realize instead of having a negative sign, I have what 1 over 2x square plus 1 half x square, the square of that whole thing. Do you see what I'm talking about? So I have here inside the root 1 over 2x square plus half x square whole thing square. So if I open this bracket, I should end up getting this because I end up getting this. I understand because of this other the previous bracket that I opened. Okay, so this square and the square root will cancel, and I end up getting here 1 over 2x square plus 1 over 2x plus half x square. What was I show that? We've taken the half out, right? We've taken the half out, then we get 1 over x square plus x square. So this is our show that for part A. Do you agree? Part B, they say the arc of the curve between the point with x coordinate 1 and 3 is completely rotated about the x-axis. Find the area of surface generated. So your x limits are from where to where? From 1 to 3. So let's use our x limits from 1 to 3. What's the equation for surface area? Rotated around the x-axis, right? So 2 pi times, can you all tell me the surface area of the solid around the revolved around the x-axis? What was the equation? Around the x-axis it was 2 pi y times 1 plus dy by dx whole thing square. Okay, with respect to x. The limits are correct. Is it from 1 to 3? Yeah, the limits are from 1 to 3. They ask us to get the surface area. So I think you can see that we've already found the answer for root 1 plus dy by dx square in the previous part, isn't it? Root 1 plus dy by dx square answer was found in part A. So that answer I can substitute here. S equal 2 pi integral limits from 1 to 3 y times the answer here is half 1 over x square plus x square with respect to x. So when you have with respect to x here, do you think you can have values like y just like that over here? No, you need to input that, and we can take the half out. Let's take the half also out. 2 pi into half integral limits. Can you all replace the y? Who is y? Y was 1 over 2x plus x cube over 6, right? 1 over 2x plus x cube over 6. I took this half out. This half. And then the other one is 1 over x square plus x square. Okay, I took this half out front here. Okay. So open the brackets now. Here, let's cut off the 2 here. S equals 5 times the integral limits are there. I think before we integrate, we need to open the bracket. Shall we expand 1 over 2x into 1 over x square is 1 over 2x cube. 1 over 2x into x square is plus the half will stay there. The x and x square cancels and gives you x on top. Do you understand? The next one, x cube over 6 into 1 over x square. The x cube x square cancels and it gives you x over 6. The last one, x cube over 6 into x square gives you x to the power 5 over 6. Do you understand? With respect to x. So I think we are ready to integrate. Okay, before integrating, I want to make sure all my x terms are up and let's add the like terms. This becomes 1 over 2. X cube in the denominator will go up as x to the power minus 3. Half x and x over 6 we can add, right? So how much is it? Half x plus x over 6 is 2 times 3. So here 3x. Yeah, can you all tell me the answer? How much? 3x plus x to the power 1 over 6, x to the power 5 with respect to x. X equals 5 times from 1 to 3 half x to the power minus 3. So when you're integrating, you add 1 to the power. X to the power minus 2 divided by minus 2 plus 2 over 3 x square over 2 plus 1 over 6 x to the power 6 over 6 with respect to x. So we are done with the limits. So I have integrated here, so I should not use the limits here. I should not use the integral sign. Okay, so I have already integrated, so I don't need to use the integral sign. So let's first simplify before we substitute. So I get here minus 1 over 4 x to the power minus 2. Here the 2 cancels. 1 over 3 x square. Here 6 and 6 multiplies 1 over 36 x to the power 6. Your limits are from 1 to 3. Okay, then let's input the answers here. The limits 5 times minus 1 over 4 into 3 to the power minus 2 plus 1 over 3 into 3 to the power 2 plus 1 over 36 into 3 to the power 6 minus 5 times minus 1 over 4 into 1 to the power minus 2 plus 1 over 3 into 1 square plus 1 over 36 into 1 to the power 6. So it's a matter of typing in the calc. Get me the exact answer. This is 209 over 9 pi minus this one is 1 over 9 pi. So basically I get my surface area as 208 over 9 pi. So this is my surface area. Okay. Okay, question number 11. The arc of the curve given by x equal 3t square, y equal 2t cube from t equals 0 and t equal to is completely rotated about the, notice this, about the y-axis. So the rotation is completely about the y-axis. So that the area of the surface generated can be expressed by this particular equation. Okay. So now first thing is you notice this is the what equation? Cartesian or parametric? It is parametric. X and y are separated. So for parametric revolution about the y-axis, I gave you the equation. For a parametric revolution about the y-axis, there was a special parametric equation that we learned. Okay? Yeah. So here for rotation about x-axis, and we learned another one for rotation about y-axis. For rotation about y-axis, this is the equation 2 pi. Can you see the equation? X times root dx by dt square plus dy by dt square. Okay. Let's use the equation. So I think first shall I get dx by dt? So who is dx by dt? I get 60. Dy by dt is 60 square. Is this okay? Okay, then let's apply the surface area equation. 2 pi integral. You get what here? Read this. Y times root dx by dt square dy by dt square with respect to, and your t limits are from where to where? From 0 to 2. With respect to, this y should be x. Yeah. This is the one with respect to the when you rotate, we are respect to the y-axis. Yeah. Okay. Rotation around the y-axis. Okay, so then let's get it done. 2pi integral x times root dx by dt is dx by dt is 60, so 60 whole thing square. Dy by dt is 60 square whole thing square with respect to t. So what do I get here? 3060 square plus 3060 to the power 4 with respect to t. So I get here. We need to replace x, right? X should be replaced because of the, x should be replaced. Everything should be with respect to t. So 3t square. And from the root, I can take 36t square out and I get 1 plus t square. Do you agree with me? I think we need to get the show that, we can take the pi integral 3t square. I can take the 36t square out of the root as what? 60. Inside the root, I get 1 plus t square with respect to t. Okay, so then we'll take we'll take all the numbers out. I can take the 6 and the 3 out along with the 2. 2 into 3, 6, 6 into 6. 36 pi comes out, and inside here t square t is t cube. 1 plus t square dt, and your limits are from 0 to 1, which is the show that you want for part A. The show that you want for part A, just 3 marks. Okay. So now for part B, using integration by part, find the exact value of this area. Okay, so let's get the exact value of this area, use integration by parts. Okay, so the method to integrate this is, we break this. Okay, look at the technique that I'm using. I break this off as t square into t. Why am I doing like this? What's the purpose in doing in this manner? Now, this is a technique that you will definitely need to use in your exam. Okay, it's a technique that you will definitely need to use in your M3 exam, in F2, F3. So you need to know about this. Now, what they tell us very clearly to use parts by integration, right? In part B, they're using integration by parts. So in part B, I'm going to use integration by parts. I'm going to break the t cube as t square into t. So what's the advantage of doing this? Do you see here when I do this? This is my fx. Basically, I'm going to use fx to the power n into f dash x integration. This integration gives me fx to the power n plus 1 over n plus 1. You see, basically, you can see here the root is the power n here. 1 plus t square is my fx. F dash x should be 2t. Basically, this needs to be a 2t here. Then to compensate for the 2t, I'll put a half outside. Are you okay with that? Basically, this whole thing, now I know how to integrate this whole thing, right? So, because I know how to integrate this particular person, this is my d dash. We are supposed to use part by integration. So, I know how to integrate 2t into root 1 plus t square by using f dash x to the power n. We can integrate this. So, this particular part is our v dash, and this guy will be my u. Are you with me? Write down v dash equals 2t times root 1 plus t square. V dash to v, we integrate. How do we integrate? F dash x fx to the power n. You add 1 to the power of n here. Root power half. When you add 1, it's 3 over 2. Divide by 3 over 2. Is that okay? And then u is t square. U to u dash is differentiation. T square differentiation is 2t. Okay, t square differentiation is 2t. Okay, then let's input the values. So the parts by integration rule is what? Integration uv dash with respect to x is uv minus integration vu dash. Okay. Let's continue here. S equals 36 pi into half. Actually, how much is 36 pi into half? 18 pi. And I'm going to integrate by using integration by parts. UV. Input the values of U and V dash are selected, and I have written my U dash, VV dash. So input UV. Who is U and V? T square U, V can be fixed, right? 2 over 3. Instead of writing 1 over 3 over 2, we can add 2 over 3. 1 plus t square to the power 3 over 2 minus integral sign. Again the V 1 plus t square to the power 3 over 2. So u minus v into u dash. U dash is 2t with respect to t in this case. In our case, we are doing with respect to t. Let's simplify this. So I get here s equals 18 pi. What do we get here? 3 t square 1 plus t square to the power 3 over 2 minus I can take the common thing. I can take 4 over 3, and inside the integral sign I get t and 1 plus t square to the power 3 over 2. Are you with me? With respect to t. Okay. So again, I think you need to integrate here. So what do we need to do here? Again, that we still have two parts here. So we'll again use, we don't need to use parts by integration, but we can directly integrate by using what? Again, f dash x respects to the power n, because you can see here the power n is 3 over 2, fx is 1 plus t square, f dash x is 1. When you differentiate 1 plus t square, you get 2t. So I'm only missing a 2. So I put a 2 here, and to compensate for that, I put a half outside. You see? Then it makes no difference in our sum. Write down the sum. S equals 18 pi times 3t square 1 plus t square to the power 3 over 2 minus 4 over 3 into half is 2 over 3. So shall we integrate now? When you integrate, add 1 to the power, right? fx to the power and plus 1. So 3 over 2 plus 1 is 5 over 2. Divide by 5 over 2. Yeah, we have to input the limits after this. T square 1 plus t square to the power 3 over 2 here. Then you simplify 2 over 3 divided by 5 over 2 is 4 over 15. 1 plus t square to the power 5 over 2. So now let's input our limits. What were our limits? From where to where? 0 to 2, right? Limits are from 0 to 2. So input the limits from 0 to find the exact value of the area. So we use the square bracket here. So 2 over 3 into 2 square. 1 plus 2 square to the power 3 over 2 minus 4 over 15. 1 plus 2 square to the power 5 over 2. Then minus the second limit 18 pi. I think you can see when you put 0 here, 2 over 3 into 0, this whole term becomes a 0. Minus 4 over 15 into 1 plus 0 to the power 5 over 2. Now it's a matter of simplifying. Simplify, get me the answer for each bracket. We get here 18 pi times 2 over 3 into 2 square, that is 4 times 2, 8 over 3 into 5 to the power 3 over 2, right? 4 over 15 into 5 to the power 5 over 2. Is this okay? Minus 18 pi into minus 4 over 2. 1 to the power 5 over 2 is 1. So can you all multiply and tell me minus 18 pi into minus 4 over 15, what do we get? Minus minus is plus. 18 times 4 over 15 gives me 18 times 4 over 15 gives me 24 over 5. 24 over 5 pi. So here I want to get an exact answer. Now I think the problem might be with the 5 to the power 3 over 2 and 5 to the power 5 over 2. So I want you to get a third answer. But if you do type 5 to the power 3 over 2 in the cell, now 5 to the power 5 over 2, you get decimals. So this is something you deal with even in P1. Okay, this is something you deal with even in P1. How do you work with 5 to the power 3 over 2? Let me write in this corner. You should know by now, 5 to the power 3 over 2 is actually 5 to the power 1 into 5 to the power half, isn't it? Because 1 plus half is 3 over 2. Basically, 5 to the power 3 over 2, in other words, is 5 root 5. 5 to the power 5 over 2, in other words, is 5 to the power 1 to 5 to the power 1 into 5 to the power half. Check and see. 1 plus half, isn't it 5 over 2? 1 plus 1, 2, 2 plus half is, yeah, 5 over 2. So this is basically 25 root 5. 25 root 5 is another way of saying 5 to the power 5 over 2. Do you agree with me? Then we get the answer S equals 18 pi. Inside bracket 8 over 3 into 5 to the power 3 over 2 is 5 root 5. Minus 4 over 15 into 5 to the power 5 over 2. What do we get? That is 25 root 5. Plus 24 over 5 pi. Okay, simplify this now. How much do we get? 8 over 3 into 5 root 5 minus 4 over 15 into 25 root 5. What's the answer? Inside the bracket? 20 over 3, 5 plus 24 over 5 pi. Okay, so then let's take the common thing out. Let's simplify. Okay, so then I can cancel 3 times 1, 3 times 6 is 18. 6, 5, 6 into 20 is 120. 125 root 5 plus 24 over 5 pi. So I think let's take the common thing out. We can take 24. I mean, we can take first take the common denominator with 5. Then we get here 120 times 5, which is how much? 600. 600 root 5 pi over 5 plus 24 over 5 pi. So now I can take, 600 is divisible by 24, isn't it? Yeah. So I can take 24 out, I can take 5 out, I can take 5 out. So 600 divided by 24 is 25. 5 stays inside, 5 goes out. 24 by over 5, that means it's just a 1. So basically, this is my answer. This is the most simplest answer. Clear with you all? Yeah, so then find the exact value of the area. So this is the exact value of my area. Okay, so this is the end of the integration lesson. I hope all of you understood the content that we learned.